this session, probably the last on Surds. I will explain or I will give you some examples related to the rules I have explained and some sums. I will solve it for you so that you can practice at home. The similar problem is very much available in your textbook or any other sources you can get it. Just I am giving you the basic kind of problems that can be solved. You can later on can go for a higher or typical problems together to practice at home. So the rules I have explained one by one. I will give you the example for that. The first rule is a raised power m into a raised power n is will give you a raised power m plus n. So if I take example 2 to the power 2 into 2 to the power 3, it will give you 2 to the power 2 plus 3 is equal to 2 to the power 5. So as per rule this is like that. So if I want to prove it whether it will give you the result exactly. So 2 to the power 2 I know is 4. Here 2 to the power 3 give 8. So all together if I multiply I will get 32 on the left hand side. So let's find whether I will get it here or not. 2 to the power 5 means 2 into 2 into 2 into 2 into 2. So 5 2 will come here. So if I multiply 2 to the power 4, 4 to the 8, 8 to the 16, to the 32. So in the right hand side also I am getting the result 32. That means these rules holds good for this case. Okay, now come to the next rule which says if it is changed with a division sign, so here only change will be, it will instead of plus it will come minus. So let's take an example, the same example here. I'll go for m is equal to 3 because I have to keep this term higher, divided by 2 to the power 2. So this will give you 2 to the power 3 minus 1, that means equal to 2 to the 2, that means equal to 1, that means 2. So let's find there. This is 8 divided by V4. So 8 divided by 4 is equal to 2. Already I have got 2 here on the right hand side. So this also holds good. Okay, now comes to the next where a to the power m into b to the power m is equal to ab whole to the power m. So I will take example 2 to the power 3, let's say, into 3 to the power 3. So as per the rule it should be 2 into 3 whole to the power 3. So 2 to the power 3 inside bracket will be 6 to the power 3. So let's find 2 to the power 3, that means is equal to 8. 3 to the power 3 gives you 9. So if I multiply together I will get 72 here. So how much? 27, sorry. It's 27. So how much I will get? 7, 56, 5, 8 to the 216. Let's check here. 6 into 6 into 6. 6 is a 36, 36 is a 216. So left hand side and right hand side are equal. So that means this also holds good. This rule is good. Okay. Now I will change it with division sign. So for this case the change will be there inside the bracket. It will be a by b. So I have to keep this term high. So I will take 3 here to the power 2 divided by 2 to the power 2. So that means it will, I will get a round figure here so that you will understand the calculation better. 4 to the power 2 divided by 2 to the power 2, that gives you 4 divided by 2 whole to the power 2. So 4 by 2 is equal to 2 here, 2 to the square, that means equal to 4. Let's check here. 4 square, that means 16. 2 square, that means 4. If I divide, I will get 4 here. So already got 4 there. So that means this is also correct. So in the next, anything to the power m, it gives you a to the power m upon n. So let me check with numbers. 4, if I take 2 here, if I take let's say 3 here, or yes 3 here, so that will give you 4 upon 2 by 3, but this is the term you will not able to understand. Rather I will check something where if I take m greater than n here, for the simplicity of the calculation I am taking this condition, and m I will take 2 times of n, so n is I am taking 2, a I will take 2 by 4. It will be ease the calculation to understand you, because that will be followed in other cases also if we take any value of m or n, but to make you understand easily I am taking this example. So it will be 2 to the power m is 4 by 2, so that gives you 2 square, that means 4. Now check here, it is under root of 2 to the power 4 means 16, so 16 square root is equal to 4, so that means left and right are matching, so this also holds good. Okay, now yes, the last rule was if I can represent this as root x minus root y, then the other one minus also will be represented as minus. So let's check with the example. If I take a is equal to 5 and b is equal to let's say 12, yes 12, yes 12 I am taking, so this will be a 5 plus root 12. Okay, now it is equal to under root of 5 plus root 12, I can write 2 root 3. So 5 can be divided into 2 parts, 3 plus 2 plus 2 root 3. So in this case I will check with another number, because this will not give you a perfect square, then it will be difficult. 2, 3 into 6, I will take 24, let's say. I will take 24 for the sake of calculation. I am taking to make you understand. So this will give you 4 into 6, that means under root 6. Okay, it will give you 6. So 6 can be divided into 2 parts, root 2 into root 3. Why I am doing that, you may have understood. So 3 can be written as root 3 whole square plus root 2 whole square plus 2 into root 3 into root 2. This is a form of a square plus b square plus 2ab. That means it gives you root 3 plus root 2 whole square root. So that means this will give you altogether. So if I take the square root, the result become root 3 plus root 2. Okay, now this is in the form of root x. So this is root x, this is root y. So this plus 24, if it is can be represented, let's check that whether 5 minus square root of 24 can be represented with a negative sign. So let's do it again. So this is nothing but the same way, 5 minus 2 root 6. So 5 become 3 plus 2, and the rest is 2 root 3 root 2. So 3 is root 3 square plus root 2 square minus 2ab. This is nothing but a square plus b square minus 2ab. So this is in the form of root 3 minus root 2 whole square. This is nothing but your root 3 minus root 2. If it is removed from the square, as because this is whole square, it is being square rooted. So this will give you root 3 minus root 2. So you can understand, if 5 plus 2 root 2 can be represented with root 3 plus root 2. So this also can be represented in the terms same, but with a negative sign in between. Okay, this is proved. So this I think understood the rules. Now I will show you some of the example where I will do the factorization of denominator. This is very useful. let say as I've taken if it is the term root b, so it needs the conjugate of it to do the rationalization of the bottom part. So this will give you, this way you can do. So that will be a minus b. So this way you can rationalize the term. So taking the real example, if I say 5 minus root 6, okay, now to rationalize that I will take the opposite sign, root 6 on the numerator, and the term bottom will be multiplied with the conjugate of that. So this will give you 5 plus root 6 divided by bottom 5 square minus root 6 whole square. So that will give you 5 plus root 6, that means 25 minus 6, this will give you 19 at the bottom, and top 5 plus root 6. So this way you can rationalize any number. This is one kind of example you may get. If you can go through your test or any referred book, you will get similar kind of problem, and you can use this concept because it is very universal concept to rationalize the surds. Now I will give a few more concepts. Let's say any surd A is represented with an infinite term of this kind. Let's say 2 plus, or rather I will take with a common representation A, root A, and dot 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 with the infinite term. Okay, so in this case, how do I can able to solve this problem? As it is infinite term, so if I do the square of this, so only the first term will be eliminated from this, because this is a square root. So the first term will be eliminated from this. So it will be like that A, and the rest of the term A like that. So if I take this, this is nothing but similar to this term, because only one A is being removed. Other terms also it is infinite, because infinite term is no end terms. So the if the numbers are so big, means so large, so that say if anything multiplied to this term, this term is so big, multiply something with this will give no changes on that. That means if I multiply 10 to the power 6 into, let's say, point something 1, so it gives not much change to the number. Okay, that means in other terms, if I take such a big number, that means if I take let's say 2 to the power any 1093, and if I multiplied it with something 0.1, let's say, so this term is such a big that 0.1 will not give much change in the number. So that means the any infinite series multiplied with some number will give you the almost the same result as the original one. So if I assume that it is A, so if I do a square, it will remove A outside, but this will again, I can say it is same as A. Okay, so from here I can say A square is equal to A into A. So bringing all terms one side, A minus A square minus A into A is equal to 0. Now if I take A common, A, it will give you A minus A is equal to 0. Now A cannot be a 0 unless until A is 0, the small a is 0. So if the only possibility is that A is equal to A, because this is nothing but the first term itself. Okay, where A cannot be 0. Okay, A only 0 if small a is equal to 0. So this could be the possibility in case of this one. Yes, it will be equal to A. Okay. this can be derived. So this is the concept. For some of the cases it will be useful for you. Now if the term is represented instead of this is multiplied together, if it is represented like that, ki a plus root a, similarly up to infinite terms, so it will be like that. In similar case I will do square, I will get a plus this term is nothing but the similar way I can write a. So the equation stands good for a square minus a is equal to, this is a quadratic equation I will get, and I can solve this equation by any means, because I know the roots of the quadratic equation how can be calculated. If not, that can be easily learned. I will teach you in other classes also, but as of now you can convert this equation like that and you can further solve this. Just to understand the concept, I am just describing this kind of problem can be solved like that. Okay, or otherwise if it is alternatively minus plus minus plus, although this only the change will come, instead of plus it will become as minus, because all other term alternatively will come. So this term is nothing but of similar to the original term, leaving a only. Okay, so these are the some of the concept which is very useful when you will come across different problem of Surds. I think I have covered almost all basic things, and if I able to come across more interesting sums on Surds, I definitely will discuss on in videos. Just wait for that, or else I will bring new topics next videos and explain some of the characteristics of those theorems. Thank you for now. Kindly visit my channel, subscribe, and give comments so that I will get some feedback. Thank you.